Hello friends, this is Subhash Jadhav. Let me welcome you all in the lecture series for Assistant Motor Vehicle Inspector Examination. Here, we discuss about probable objective type multiple choice questions. Today we are going to discuss about ignition system. So, let us start. The first question is, choose the correct statement from the following. So we are supposed to choose the correct statement. Maintenance problem in magneto-ignition system is more. Obviously no, because there is no battery as we discussed earlier. So battery related problems are less, and therefore compared to the magneto, the problems will be less. So maintenance problem is not more. So this first one is a wrong statement. Magneto-ignition system occupies more space. Obviously not, because we have a small magneto connected to the crankshaft of the engine, and from there the electricity supply is directly taken to your ignition system, contact breaker and distributor, etc. Therefore the space required is less, and therefore the second statement is also wrong. Magneto ignition system is used in large four-wheelers. As we know, battery system is more preferred over magneto ignition system, because in magneto the supply, whatever is given to the spark plug, is not proper as per the requirement. That is, the intensity of the spark is going to change. At low speed the intensity of the spark is less, at high speed the intensity is more. So that variation is there. In order to avoid this thing to happen, what we do, we generally use battery, and that is why battery ignition system is more preferred in four-wheelers. So this is also a wrong answer, and therefore the correct answer is magneto ignition system has poor quality of spark during starting. So we know that during lesser speed the EMF induced in the secondary will be less, and correspondingly the spark quality is of less intensity, which makes the starting of the engine difficult. So the correct answer is magneto ignition system has poor quality of spark during start. Then we have next question to be, dwell is the time. So talking of a contact breaker assembly where we have a cam and a follower arrangement, and to this particular follower we have connected what we call as a contact breaker, and whenever the contact over here is broken, correspondingly the supply in the primary is being changed, and accordingly the EMF induced in the secondary, which gives the spark of a proper intensity. Here we have 6 lobes corresponding to here on this particular shafts. Here 1 lobe, second, third, fourth, 5 and 6. So 6 lobes corresponding to 6 cylinder engine, and whenever the follower is in contact with the lobe, it rises up and the contact is broken. Whenever the lobe passes by and it comes in this particular region, which we call as a dwell. So during the dwell, what happens, the follower is at lowermost position, and correspondingly it is not going to move. So from here to here the follower is stationary. So what is a dwell? Dwell is the period when the follower is stationary, that is contact breaker point remains closed. So since it is at bottommost position, the contact breaker point remains closed. But as cam lobe comes into picture, that is this rotates and comes over here, then it pushes the follower up, and correspondingly when this moves up above this particular fulcrum, the contact over here is broken. So from here to here it is open, here to here it is open, and here to here it is closed, and this particular period is what we call as a dwell. So the question is, dwell is the time for which the point remains closed. So from here to here it is remaining closing, here to here it is open, here to here it is open. So correspondingly we have around 32 degrees of the dwell during which it is remaining closed. So the correct answer is dwell is the time when the contact breaker point is remaining closed. The next is, the contact breaker gap is set most accurately by means of so we are talking of an instrument used, or the device used to set the contact breaker gap. In order to understand how the contact breaker gap is set, we should understand the relation between the contact breaker gap and the dwell. So here what is shown is a normal dwell with a normal gap. That is, when the dwell is normal of intermediate value, here the contact will be also gap will be also normal. But when the dwell is excessive, it is more, the angle is more, what happens? The amount of time, or sorry, the angle required available for the cam lobe is less, and therefore this gap, very small amount of time is only available for this particular thing to move. That is, contact breaking will be happening only a small amount of time, and that too with a small gap. So when the dwell is excessive, gap is small, and reversely, when the dwell is very small, the gap is going to be wide, because from here to up to here it will be available for opening, and that means this much time it will be remaining open. It will move further and then come back, so the gap is going to be more. So there is a relation between the dwell and the gap, and therefore the dwell is used as a mean for adjusting the contact breaker gap. So here you can see how the dwell meter is used. So whenever the contact breaker is closed, one point of this particular dwell meter is connected to earth, and the second point is connected over here to the point from where the coil is being supplying to the contact breaker. So the primary point which is coming to the contact breaker. So in between these two, zero voltage will be shown when the contact is closed. So when the contact is closed, the meter will be showing a 0 voltage, while corresponding to the gap, when it is open, you can see over here, when it is open, the same location of the this particular meter will show 6 to 12 volt. That is, corresponding to the amount of the gap, the voltage is going to change, and here it is 0 and here it is increasing. So the amount of gap is now becoming proportional to the voltage, and thus the dwell meter, which is the instrument over here, is generally used for adjusting the gap accurately. So feeler gauges are not used, steel ruler is not used, dial gauge is not used, while a dwell meter is used in this particular fashion to adjust the gap in case of a ignition system. The next question is, the dwell angle on a 6-cylinder engine compared to a 4-cylinder engine is. So here we have a shaft on which rotor shaft on which we have 6 lobes, and here we have a rotor shaft of 4 lobes, and approximately the dwell angle over here is 32 degree, while here it is around 54 degree. So now we can see that what we are talking of is dwell angle on a 6-cylinder engine compared to a 4-cylinder. What will be the value of the dwell in a 6-cylinder engine and a value of a dwell in a 4-cylinder engine? So obviously we can see, since throughout the 360 degrees we have to only fire 4 times, the amount of time available for the dwell is going to be more, which is approximately 54 degrees, while here it is approximately 32 degrees, because here throughout the 360 degree we have to fire 6 times. So compared to this, that is 4-cylinder engine, 6-cylinder engine dwell will be less. So it is 32 is less than 54. So the dwell angle of a 6-cylinder engine compared to a 4-cylinder engine is going to be less. So that will be the correct answer, that is B. Next question is, the centrifugal advance mechanism provides ignition advance proportional to what? So we should understand what this particular advance mechanism is. So we know that when the engine speed increases, then the time available for the combustion becomes less, but theoretically the time required for the combustion will remain almost same. So in order to provide this extra time which is not available, what we do is we ensure that the spark is given early in order to make up the required time. And to make this particular spark given early, we have what device over here which we call as advance mechanism, and this particular advance mechanism is working on the principle of centrifugal force, and therefore it is a centrifugal advance mechanism. Now in order to work in a centrifugal fashion, what is there? Here we have the flyweights. So when the speed of this particular shaft increases, here this particular rotor is driven by the crankshaft and camshaft, so the speed of this particular shaft will be equal to that of a speed of the camshaft. And as the speed of this particular increases, the flyweights are going to fly away, and when this particular flyweights are flying away, the base of this particular is going to rotate. So here you can see this has moved towards this side when the flyweights are flying out. So when the speed increases, the flyweights fly out and the base is going to rotate, and on this particular base we have attached what we call as a the cam and a follower arrangement for making and breaking the contact breaker. So that is going to rotate, and that results in the advancing. So the advance is going to be proportional to speed. So the centrifugal advance mechanism provides ignition advance proportional to the engine speed. That means more the speed, more will be the advance. It is not related to load or so. Here the correct answer is B. The centrifugal advance mechanism works on the that is, it is proportional to the speed of the engine. Next question is, the distributor serves the following purpose in ignition system. So we have here what we call as a distributor arrangement. So in this particular distributor, what all things are there? Here we have what we call as a distributor rotor, and we have a distributor cap. So from this particular cap, we have the supply going to different spark plugs. Now, as we come below, here we have what we call as a contact breaker assembly. So this particular assembly is over here. This whatever we see over here is this, and on the lower side of it we have what we call as an advance mechanism. Preferably here it is diaphragm is shown. This is a vacuum advance mechanism. So here the three assemblies are there. On the upper side we have a distributor arrangement with the help of a rotor, and we have a contact breaker assembly over here, and here we have an advance mechanism, and all the three are working on the same shaft. So the distributor serves the following purpose in the ignition system. It operates break and make mechanism. So since the contact breaker assembly is over here, that is being operated by the same shaft. So the distributor is operating the break and make mechanism. It distributes high tension current to spark plug at correct timing. It is over here. So when this rotates, comes in. So here when it comes to in contact with this spark will be firing. When it comes to contact, this spark will be firing like this. As it moves, as the rotor moves and makes a contact with the corresponding points in the cap, corresponding that spark will be fired. So it distributes high tension current to spark plugs at correct time is correct. So both these are correct. So the correct answer is both A and B. So the distributor serves to make and break in the contact breaker assembly and distribute in the distributor assembly. So that correct answer is C. Thank you.